Um, you probably noticed that there was not a ed lesson announcement last night, as we've been doing for the last couple of weeks. To be honest, I found it hard to come back into lecturing after 2 weeks off of doing it. And so things kind of got pushed out a little bit. We're going to try some interactivity within lecture and then do some normal lecture style as well. And then we'll kind of mix in some of the flipped lecture out, some videos outside, some videos within. We'll give a good mix. One of the things we heard from the feedback, as you know, we had a mid-quarter eval, and we had also a short forum within the last couple of weeks to try to get some ideas from you on how things are going. And so we got a mix of feedback on whether normal lecture style is more useful than the flip style and vice versa. And so we're going to address that by mixing things up a little bit. So bear with us as we try to sort through the technology, and let's get to it. I'm going to share my lecture slides. Okay. So today we are going to be introducing this topic of APIs, of JSON, and of fetch. So we'll do a couple of reminders, and then I'm going to spend a little bit of time kind of as a segue into our new topic, talking about question 5 in quiz number 2. That was that list of statements about promises and trying to assess whether they are true or false. So we're going to go through that kind of as a review of last week and as our segue into APIs and whatnot. So a couple reminders. First, homework 2 is due on Wednesday. And one thing that I do want to emphasize there is that we expect you to implement the functions, the required functions, exactly as they are specified in the specification. I know there's some flexibility on functionality and how you implement that, but we really, for those required functions, want you to implement what we ask for. And the reason is because we depend on certain behavior to exist and certain behavior to exist in exact ways in order to make sure that every other part of the homework exists and works and can be graded easily and fairly. So please make sure to follow the spec as close as you can, and we'll be very grateful for that. Homework 1 grades will be released. I'm going to do that today. So you should be seeing those grades very, very soon. Normal rules there will apply for regrades. We'll open them up 24 hours after I release, and then they'll be open for a week. Just reminding that quizzes are out every 2 weeks. We had some people miss the last one, and so I just want to remind again that every 2 weeks we were going to be having a quiz, and you can drop the lowest one. And so if you're one of the folks who did miss last week's quiz, know that the lowest is dropped, and so you have that option available to you. Also, instructor office hours are available after lecture every Monday, Wednesday, Friday. They tend to be pretty light. And so if you find that the WPL hours with TAs are having a long wait, feel free to pop over and talk to myself or Andrew. And then last reminder is on ed questions. Please review again, if you haven't, the post that I have in the ed discussion board for how to ask good ed questions. And one thing to note here is also about asking for questions like, is my implementation of this correct? We're probably not going to answer a question like that. Questions like that are generally discoverable through reading the specification for the assignment and checking your own behavior off of that. So review that post so that we can better help you with good, meaningful questions. Okay, so quiz 2, question 5 looked like this. There was a set of, um, how many is that? 7 different statements about promises. And some of them were true, some of them were false. And so I want to make sure that we're all on board on which is which and why. So, first thing, true or false? Promises always end up in the resolved state. I'm going to give us a moment to kind of think about it and remind ourselves of what we might have put on the quiz. And the answer here is false. So it's kind of a little bit of an interesting thing that, and this was one of the questions we had last week during lecture as well, that promises may never resolve. They are always required to resolve at some point, but they might not get there. So if you imagine you're sitting in a restaurant and you order some pizza, and the pizza never arrives and you end up having to leave before it does. So they might still be working on it. They might still be trying to make it happen. But the promise never actually ended up in the resolved state, or it got rejected. And so it's not actually resolved, but it was rejected. So this statement was false. Next up, promises have 2 states, pending and resolved. This one is also kind of tricky. It's based on the terminology that promises have, and some documentation has a little bit of different words that they use. However, the false part of the statement is that there were only 2, because there are, in fact, more than 2. We have pending, resolved, and rejected as the ones that we discussed. There's kind of another one, but we didn't discuss about it, and we won't discuss it. But there are, a promise can always go into one of those 3 states. It starts in pending, moves to resolved or rejected once something happens. Next up, in order to use promises, we must always write new promise at some point in our own code. And so the us and the TAs kind of discussed this one a little bit about what it really meant, because at some point in the code that we use, there may be a new promise. However, what we're going to find moving forward is that for the most part, we probably won't need to write new promise ourselves ever again. That's because we will use things like async await or fetch, which we will explore more today, possibly tomorrow, or Wednesday, sorry. We may never have to write new promise again. We're going to use things that use promises. So it was important to understand how promises are made so that we can understand more about what they are doing when we use them. But for the most part, moving forward, we're just going to use them. So the executor function, those parameters need to be named resolve and reject and be in that order. This one is partially false. So the true part of that is that the first argument will always be used to resolve the promise, and the second argument will always be used to reject the promise. However, they don't have to exist. If they don't exist, then that promise can never be resolved or rejected, but they don't have to exist. You could potentially have a promise that just an executor that just returns, and that's not going to give you the promised behavior, but you're not going to get any kind of errors. And if you only want a promise that's only ever going to resolve, you only need to specify the first parameter, and it doesn't have to be named resolve or reject. But it's extremely helpful to name them what we expect them to be and use both, because we expect that that promises will be able to eventually reject or resolve depending on what happens. And yes, we will be giving partial credit for question number 5. We're still weighing what that partial credit exactly looks like, but yes. Um, Next up, the catch function must always be last in the chained then catch. Um, so in this one, the catch function um, doesn't have to be last. We will pretty much always see it last, and in most of our cases we will see it last. However, technically you can write it um, have a then after it, and Andrew demonstrated this last week a little bit, and the behavior is a little bit strange. It's different than what you'd expect for the dot thens that happen before the catch, and so that's why we won't see it very often. But technically, it is possible for the catch to then return a new promise that may in the future resolve differently than the original promise. Um, so uh, this one is false. Um, so I'm going to go backwards just slightly to address this one. Um, when there's so these questions that are partially true or partially false, since the quiz had just a single check mark, we aren't able to discern which part of it you thought was true or false. It's partially a limitation on the platform, so we have to be able to grade this on a all or nothing for each individual question. um, and and so therefore if any part of it is false, we expected this answer to be false. um, Next up, we only have two more. Only one catch can be included in chained functions. This one is also false because um, uh, each catch could potentially make a new promise and create a new chain of promises after that. However, the subsequent ones will only be called if the previous ones failed. So it's certainly like the dot then coming after a catch. It's possible. It's kind of weird, and we won't really see it that often, but it is possible and does happen. Um, Finally, a promise cannot change state from resolved to rejected or rejected to resolved. Uh, this one is, in fact, the only one that is completely true. Once a promise is resolved or rejected, it cannot move to any other state. Any questions about that? Christopher asks, so will each question be worth like 0.115 points? Um, so obviously, if you get all of them right, then that's a full point. It's not exactly going to be 0.15 points. The smallest point increment we use is a half point, and so we're gonna at some point have a cutoff of how many you get wrong to qualify as a half point. Just because 15% on a point is kind of pretty granular, and so we're gonna look at just half point increments. Uh, Potentially. TBD. So Kevin says, wasn't there a demonstration last lecture on something rejecting and then resolving?
There was likely an example of us rejecting a promise and then showing that when you chain that promise with a then call, that then call returns a resolved promise rather than a reject promise. But that is a new promise. Completely, it's related to the first one, but it is a new promise with a different resolved state. But once that initial promise was rejected, it could not change states.
Yeah, so it's one of the kind of interesting things about those chains is that after the first dot then or dot catch, you're actually operating on new promises, and so That's where that understanding of how promises are built up from zero is useful knowledge. Other questions? Otherwise, we're going to move on. 2 more questions, almost identically, almost at the same time. I'm going to do them quickly because I do want to. We do have other content to work on. Hitesh asks, with 2 catches, you have a chain following each catch with thens that will be called upon because the first chain was resolved. Not sure I follow.
I think that's related again to the fact
Yeah.
that you can have the initial promise reject, but then using catch, you can return a promise that is resolved. And then you can, depending on whether the next promises in the chain reject or resolve, you can kind of flip states. But those are new promises. So it's different, and I know that it's a little nuance there, but a true promise, once it has changed states, can't change.
Yep. So a plug for Tal's detailed ed post in lecture 12 question about it. And so there's more details there. Lauren asks if the questions were asking if it was possible at all or if it's what we would implement in our code. The questions were whether it was true about promises at all. So yeah, not necessarily checking if it's something we would implement, although there was that one about whether we needed to or not. And it's not necessarily asking about good style, it's asking if it's possible at all. Okay. I'm going to move on. If you have further questions or concerns about this, please reach out to us or post a question in ed. So for today, we are going to be talking about this thing called an API. And to start off with, I'm making the assumption that you've spent some time reading the readings beforehand. In particular, the one about the non-technical discussion about what an API is. That particular reading talked about how an API is, they used an analogy of the restaurant, of you sit down, you look at the menu. The menu is a list of things that you could potentially get. And then you talk to the waiter and they go out and get it, potentially returning, potentially talking to other people in the meantime, potentially getting your order wrong. And then what does it mean to look at the same menu but at a different restaurant and it doesn't quite work out? And so that's kind of an interesting analogy for APIs. And so what I'd like to do right now is to break out into discussion rooms, and we'll try to make sure there's some TAs distributed throughout them as well. And we're going to discuss like what in the context of our websites would be a reasonable use of an API. When would it be useful to be able to talk to another program? Come up with some examples of what the program might do, and what are some of those reasons that the functionality couldn't be within our own program, in our JavaScript that we write for the code. Why does it have to be in someone else's program? So consider for a moment that we have used examples already, used APIs already. One of them, for example, is using query selector all on the document. This is an API used to talk between our website, our JavaScript, and the browser. So we've used APIs already, and so we've seen this come up a little bit. But think about what functionality in a website might change, might be affected by an API, or what an API might provide in that sense. So if you head over to Ed and check out the lessons, there is a question here that you can use to type out or think about your answer on your own, as well as in the discussion groups. Let me start getting the breakout rooms going. No, this is not graded. Our Frameworks APIs, sort of. Breakout rooms automatically into let's do those. And we're going to our breakout rooms.
Hey, hi, how's everyone doing?
Good. How are you?
Doing well.
So what do we think? What type of programming would require APIs? Any ideas? So I guess the first example that he mentioned was the query selector and interacting with the DOM. So maybe that's a good example. We can talk about why you need an API to do that, and you can't just write it in your own code.
Can you repeat that? I couldn't.
Yeah, sorry. So I was saying maybe we can use the example of interacting with the DOM with query selector and other types of functions, or and understand why those require APIs rather than just writing it in your own JavaScript code.
I think that's might be an option. Another thing I was thinking of is that why would we want to interact with other programs? Is like if we want to link two things together that we don't like. For instance, what if we want to link my website to a paying service like Apple Pay or PayPal? And I think in these certain type of ways, we need some APIs so we can connect to the other service and get information from there and pass this information to get like a reference or a verification that allows us to do these interactions.
Yeah, that makes sense. Yeah, and I think in the first example, you can imagine that if every single JavaScript file had to write out in detail how to interact with the DOM, then it would get extremely tedious, and you wouldn't have any standardization in your sites across the web. So it makes a lot of sense to have one unified API, kind of like an interface in Java that interacts between any JavaScript file and any HTML document object model. So yeah, it's sort of the idea of connecting two things that aren't supposed to, or that shouldn't be intrinsically related in your JavaScript file. Then that makes sense to use an API.
Yeah, I do agree with that.
Any other ideas as for examples, or why we shouldn't use that type of thing in our own program? I think maybe some like security stuff would make sense to have controlled externally that way. So where you port in methods, functions, and classes from elsewhere. Obviously, you want some customization in how you design security on your site, but you also want the web structure itself to be able to have some control over how websites interact with each other. You wouldn't want to let people be able to design bypasses or things like that based on their own JavaScript.
Something else we haven't really mentioned is like data collection. So like, for example, a lot of APIs have collections of data that you can just like pull from instead of like you going out and collecting that data yourself, which is like really helpful for like database, for example.
That makes a lot of sense. Yeah. I guess, and then maybe more explicitly, why don't you want to get that data yourself? Is it like not possible, or is it just tedious, I guess?
Yeah, I guess it would be tedious and time consuming.
Takes a lot of computing time.
Yeah.
Or I guess maybe you have functions on your site that require information that you can't possibly store locally on your server.
All right, we've got about a few more seconds until it automatically ends. And looks like people are coming back in. Let me check how we're doing. Okay, so it seems pretty good. Sounds like we had some good discussion in a lot of the rooms. And so I want to let's see, let's go back to here. Sorry, doing window management. How did it, is there anyone that wants to raise their hand and share from their group? I'll take the first one or two. Keith, what would you like to share from your group discussion?
So one of the scenarios that we came up with was to grab data on the web that's already been like computed in the way that you want instead of doing it yourself, because it could save time and a lot of headache writing code to parse that data locally.
Yeah, absolutely. So that's a great example where you there's some data that you need access to, but it wouldn't be great to access it and parse it on the website side rather than on the server side. Servers are generally a lot more powerful, and we'll talk more a little bit about this client server terminology in a second. That's a great example. Anyone else want to volunteer to share out? Winter.
I think it's really a big point of security and bandwidth consideration. I think the best example I heard was if you're like registering for a website and while you're signing up, the form's like, that email's already taken, or that username's already taken. Obviously, you don't want to just hand the client every single email and username, because that would be bad.
Mm-hmm.
Web scraping at least. But they still need to know that that's happening, because then they don't have to submit a form and then reload the whole page every time that they happen to have a collision.
Yeah, absolutely. And because we have this notion of personally identifiable information or protected information, and we want to make sure that that we protect it, and that's also a great example. So these were both very good. And in the interest of time, since we only have 18 minutes left, we're gonna move on. And I'll take a moment after lecture to look at what people wrote in the ed lesson, and maybe summarize some of the things that people wrote. So we did that. This is where we're going to end up at some point, where we have some JavaScript code on our client that we write that is going to call an API. So an API needs to be accessed by code in some way. And this is the general pattern that we're going to look at for that. But where does this come from? So we're going to talk about APIs and where they come from. The APIs that we're talking about, these third-party APIs, where we're accessing data or information stored on someone else's server, these are all accessed in the same way that our web page was accessed in the first place. So if you recall back to almost the very beginning of the course, where we had, what does the browser do when it pulls up your web page? Well, one of the things it does after doing that DNS call to get the IP address is it issues this HTTP request, this hypertext transfer protocol request, saying that I would like to get this page from this host. They all follow these protocols, even our API calls. And so when we make an API request, it's going to look pretty similar to that. And there's lots of different ways of implementing APIs. The ones that we're going to use today and in this course are all JSON over HTTP. And so in the previous example, if we were getting a website, we would get HTML over HTTP, because our website is first and foremost HTML with some added bits to make it look pretty and do some stuff. But you could imagine potentially that this could return something else, some other kind of data format like JSON. So our overall pattern for APIs, though, is that we have a client, our website, and it wants something, and we have a server that has something. The typical analogy, as we saw from the readings, is a restaurant. So I, as a restaurant goer and eater, I want to eat. I want to have some pizza. And the restaurant has some pizza. They would like to provide me some, because then they get paid and they like to serve food. So at each step along the way, we could imagine doing these things. And before we had this notion of promises and asynchronous programming, we could maybe look at doing this in a series of callbacks, where we say we have some sort of timeout that waits for the menu to be delivered to us, and then we wait for the pizza to be delivered, and then we wait for the next thing and the next thing, and we issue a new callback on each one. That ends up being kind of a mess. It's all over the place. You end up with this very deep Christmas tree style code structure, and it's not pretty. So we introduced the notion of promises, where we can have this state of, I've put in the order for my pizza, so I'm now pending my pizza, and the pizza either arrives successfully or maybe it gets rejected because they ran out of cheese. And so we've talked a little bit about this. So we might look at a promise chain for the order pizza example of being like this, where we're saying on the first, or once we order the pizza, once it comes back, we're going to make sure that it matched my order. So I ordered a plain cheese with pepperoni pizza. Does it have pepperoni? Does it have enough cheese? I don't know. Let's inspect it and find out. And then I'm going to eat it, and then I'm going to pay for it. And then if anything else goes bad along the way, I would catch it. And so to answer your question, Nikhil, if we had that catch earlier in this chain, we would only be able to catch errors on whatever came before it in that chain. So because the inspect, eat, and pay don't have their own catches, I'm not handling those differently. I'm just saying that if anything along the way, if I inspect it and it's a bad pizza, if I eat it and it turns out the cheese had gone bad, or if I go to pay for it but the price was different, then if any of those go wrong, I was going to catch bad pizza at the end. So it's kind of a thing that'll handle any of my errors. We could potentially conceive of constructing this in a way that would handle them all differently. But for most of our examples, we're going to have that one error callback, that one catch at the end to handle all of our errors. Yes, correct. Good, got it. All right. So when we use promises and APIs, and this is kind of the reason we introduced asynchronous programming and promises and async await last week, because it all builds up to these, where we have no idea when an API is going to resolve. So that notion of a promise that is pending but might not resolve in the future, it comes down to things like this, where we don't know where the server is located. Maybe we are in New York and the server is in Australia, and it's going to take a long time to get here. Maybe there's a bunch of Zoom calls happening simultaneously, and the internet gets jammed with traffic, and it's going to take even longer. Is the server running slow? Are lots of people ordering pizza today? We just don't know when these API responses are going to finish, and so we need some asynchronous programming to be able to handle this properly. And so we start to look at this notion of fetch. And fetch is a particular kind of API. This is an API provided by the browser. And it allows us to issue an asynchronous request to receive data from a server, to ask an API to give us something. Fetch is an API, is a function that returns a promise. And so when we, and I'll fix the formatting here after lecture, but when we use fetch, it is usable just like any of our other promise chains, where we have, we ask for a particular URL, and then we do something, and then we do something else. And if anything goes wrong, we catch all the errors that happen. And so fetch is a call that it's actually relatively new. It was created only within the last 6 years, which in computer terms feels long, but is actually very new in terms of how old the web is. And it's a reasonably simple, once you know promises at least, reasonably simple thing to use. We give it the URL that we want to, that represents the API. So in this case, we might have an example cafe to order food from, and we give it that URL. It returns a promise that will give us the data, hopefully. if everything goes well. So this is what our skeleton starts to look like when we are calling APIs. We have the URL of that API. So like getting a website where it's mywebsite.com/index.html, an API would be similar. It could just be mywebsite.com/API. And so the first thing we do is we give it the URL. And we'll talk about these possible parameter things in a second. Maybe not today, given how much time we have, but we'll talk about those in order to change what we're getting from the API. But once we pass that over to fetch, we can then do a few things. The first thing we're doing here in this skeleton, the very first thing before anything else, is to make sure that the request came through perfectly fine and everything is okay. And if you recall, again, back to one of our very early lectures, I'm going to pose a question and see if folks can have the answer in chat. But when I do an HTTP request, what do I expect to receive back? Even before the HTML, before I get the actual file, when I get the thing back, yes. Yeah, so we're looking for some kind of status code. And we would prefer for it to be 200, but we can also get other error codes like 404 or 500 or 403. It's a long list of them on the internet. You can find them. So the first thing we do here, once we issue the fetch call, is to check that the response came back okay. And that's behind the scenes, it's checking to see if that was a 200 and not other particular kinds of codes. But we're checking to see that it's okay. So it's the same as, we receive our pizza back. We're checking that, yes, I received a pizza. Great. The next thing we do after that is check that it's the right type of pizza. And so what I mean in this example for the API is that in some cases, we might want JSON data. So the API's documentation may specify that it returns everything in JSON, or potentially one of those possible parameters is to change it to a text format rather than JSON. And so the second thing we do is to attempt to translate this response into the data that we expect. So parse it into JSON. The third thing we do is actually do something with the data. So you could imagine, for example, updating the DOM with images of the pizza that we ordered, or with creating a table of the data that we just fetched from the server, or displaying an image in the corner of the website based on the account's profile photo. So in this third, then we are actually doing something with that data. And finally, if anything goes wrong anywhere along that process, we can catch it and do something like displaying an error message, putting in a placeholder image, or logging to the console if we have nothing else to do. So this is the skeleton that we're going to use for most of our and almost all of our fetch calls. And since this returns promises, we could see maybe throwing in some async await in there as well. But we can clean it up a little bit too. Yes, Aaron, this is exactly the thing where we don't really need to write new promise, because we are using promises here. Fetch returns promises. We have a .then chain. We have a .catch. We have all of the things that we learned about in promises, but we're not writing new promise here. And so we can clean up this code a little bit to make it a little bit more readable, removing some of those abstract function or anonymous functions. And you can see that the fetch call here is in some ways always going to be the same. We have some URL that's specified in some variable with some parameters that's also given as some variable. And then we check some status, we can maybe return the status or throw a new error. We parse it, and then we do something with the data or handle some errors. So it's kind of a much nicer, cleaner version of the skeleton. These are in the slides that we can follow up with later. But we've talked about, I've mentioned this JSON thing. And what is it? So one of the readings talked about this JSON thing. So hopefully you read that. And if not, it can help. In this case, function fetch the data does not return anything. So when we're looking at JSON, so if you recall from the readings, JSON stands for, or JSON, depending on how you want to say it, the JavaScript object notation. And really all JavaScript objects kind of look like this if you build them. And so if you recall, when we were writing our client-side JavaScript, we have that, that anonymous function up top, and then we have the curly braces and some functions within it. It starts at some point to kind of look like a class or an object that we might have seen in Java or other classes or other programming languages. And so it kind of looks the same. And this is a very common data format that we use across the internet to transfer information between two different things. So for example, here's a JavaScript object. And this is not JSON necessarily, but it's an object written in JavaScript where, again, like those classes in Java, we can have properties that have their own values. We can have functions that provide the behavior, and then we can use it. We can create instances of it to have specific cats in this example. And there's a big difference here between a JavaScript object and a JSON object. So what I'm going to do is, in our last 2 minutes, demonstrate what the difference is between these two. So I'm going to copy this out, and I'm going to open up the DevTools. I'm going to define this JavaScript object. So now I have a kitten, and you can see that the console, and I'll make this bigger, the console has appropriately parsed this out for us. And we can do things like call our function. And so we have an object that has functions on it, just like we would expect. Document.querySelectorAll is a method on an object. The object is the document. And when we look at JSON, we'll primarily be using two different functions. We'll be using parse and stringify. And let's look at stringify first, because as I mentioned, JSON is the JavaScript object notation. So it operates on JavaScript objects. But I also mentioned that there was a critical difference here between the two. So if I do JSON.stringify, which is what it's doing is taking a JavaScript object and returning the string version of it. So for example, I might have something that looks like this. It's a very simple bit of JSON. And if I stringify that, then I get something that's in quotes, which looks like our string, and it has all of the things that we expect from there. Now, if I take my complex JavaScript object, which has properties as well as methods, I stringify that, and there's something critically missing out of here, and that is any of the functions. So when we operate on JSON, we are only creating strings out of the parameters and the properties that are part of this object, not any of the functionality. And that's because JSON is a what we call a portable data format, where any language can potentially use this. And if we define functions in this string, all of a sudden we're crossing languages and mixing up behavior. And so JSON was defined as only the data, not the functionality. So that brings us to the end of our time today. As usual, I'll stay on and answer any questions that you might have. But thank you so much for being with us today, and hopefully the breakout discussion was useful, and we'll follow with it next time. Thanks, everyone.